Hey, guess who forgot to do the daily question today? All right, sorry. Here it is. Maverick and John are traveling from the bowling alley to the library. John travels in a vehicle whose velocity is in meters per second and is given by v of j is equal to 40 minus t squared. So we've got John, and his equation is this. Where t is in seconds. Got it. Maverick travels in a vehicle whose displacement from the bowling alley. Okay, so they're giving us the displacement function for Maverick. His displacement function is given by S sub m is equal to 2t squared plus 60. Okay. When t equals 0, both vehicles are at the same point. Okay, this is a sneaky little clue. A clue. Find John's displacement from the bowling alley when t equals 10. So in order to find John's displacement, we need to find John's displacement function. To get to the displacement function from the velocity function, we're going to need to integrate the velocity function. So let's go ahead and substitute in that velocity function that they gave us. Then we're going to integrate with respect to time. We should get 40t minus t cubed over 3 plus c. Okay, I don't have any further information about John, but I do know that both vehicles start at the same point when t equals 0. So this is John's displacement function. Let's look at Maverick's displacement function and see if we can use that to find c. Okay, so we have S of 0 for Maverick would be 2 times 0 squared plus 60. Okay, so S of 0, or the displacement when time is 0, is equal to 60. Okay, so if that is going to be the same displacement for John, we can go ahead and tack that on for C. So now I have S of j is equal to 40t minus t cubed divided by, oops, that's a 3, plus 60. Okay, I'm trying to find John's displacement from the bowling alley when time equals 10. So let's go ahead and evaluate this displacement function for John when time is equal to 10 seconds. Okay, and we should get 380 over 3 meters. Okay, little kinematics question for you. Let's go to number 6. Let f of x equal x squared plus 3, all raised to the power of 7. Find the term in x to the 5th in the expansion of the derivative f prime of x. Okay, so first we're going to want to take the derivative and see what we're working with here. The derivative of f of x is going to be 7 times x squared plus 3 raised to the 6th power, all times the derivative of the inside. Let's clean that up. Okay, now what we're going to want to do is, the expansion of this guy first, and then we're just going to multiply him at the end. Okay, so let's do the expansion of x squared plus 3 to the 6th power. We have our binomial expansion formula. Okay, we know that n equals 6, and we want 14x times our answer to equal x to the 5th. So we want an x to the 4th in our expansion because he's ultimately going to be multiplied by that x from the 14x out front, right? So this is what we want ultimately. Okay, so let's go ahead and know that our r is going to be 4 due to our desired exponent of 5 here. Let's go ahead and substitute these into our equation here. We've got 6, choose 4, x squared to the n minus 4 is going to be 6 minus 4, which is 2, and then 3 to the 4th. Okay, so we would just do x to the 4th right here. 3 to the 4th times 6, choose 4. That's going to go in our calculator. Hi, we were doing systems of linear inequalities. Okay. All right, so we would do menu 5, 3 to get to combinations, 6, comma 4. comma 4. Okay, and that's going to be 15 times 3 to the 4th, and that's going to give me 1215. So now I have x to the 4th times 1215, and then don't forget that that needs to be multiplied by that 14x out front. Okay, so now we just do 14 times 1215, hi, and we get 17010. 17010. Okay, x to the 5th. That's it.